All right, so let's say you finally decided to move away from GitHub hosted runners and you want to self host your runners, hopefully using Runzon. And all the initial tests are coming out good, everything seems to work. But now you got to migrate. And you realize you're a huge enterprise that runs thousands of workflows a day. And you got to change all the workflow labels and everything. So just so that you can use Runzon or a similar self hosted solution. So, how do you do that? How do you manage a whole fleet of self-hosted runners at enterprise scale? So, let me show you another workflow. All right, so here's another simple workflow. So, we've got like two test jobs and two build jobs. So, the test jobs are they need to be run on conservative instances or cheap instances. So, we've got a very conservative CPU and RAM constraint with general purpose or T family instances for both the test jobs. And we've got a set constraint for a CPU RAM for a build job with general purpose instances. And then we've got another job that is running on an ARM instance. So, for example, I have a job that needs to be built on ARM, but it's not something that is usually done. I just want to test it out. I just want to see if my application can be built on ARM or can run on ARM. So it's not something that usually happens, for example. So in this case, what happens is this is all well and good, but if you've got thousands of workflows, uh, changing all the workflow labels here becomes tedious and repetitive. And of course, human mistakes are bound to happen, even though your agents are writing all the workflow files, right? So, what Runzon does is it has another product called Runzon Fleet. So what Fleet uses under the hood is runner scale sets. So scale sets were introduced by GitHub in February, I guess, this year, and they're a bit different from your general webhook-driven GitHub actions. So GitHub defines a scale set as a group of homogeneous runners that can be assigned jobs from GitHub actions. The number of active runners owned by runner scale set can be controlled by auto-scaling runner solutions such as Actions Runner Controller or Runs On. And you can use runner groups to manage runner scale sets. So what Runs On Fleet does is, firstly, it can only be deployed via Terraform, as opposed to Flex, which can also be deployed via CloudFormation. So what we do here is we can define a runner group on the org level or the enterprise level. So in this example, I'm showing an enterprise level runner group. So we use an enterprise level pat, and we also create the runner group right from Terraform for the enterprise. And if you see here, we can also define or now also define our whole runner catalog right through Terraform. So on the platform level. So this will allow a platform team that governs the whole enterprise to manage runner infrastructure from one place instead of having workflow authors managing the runner labels. So the runner shapes are pretty similar to, or like they are similar to what we defined in Flex. So cheap runners, cheap conservative runners for our test jobs, and a set runner for our build job. And then we define the fleets. So these are the scale sets that get defined behind the scenes. So this uses the runner group that we just defined above, and a different scale set for our test jobs and our build jobs. So I've already deployed the stack. So let me show this to you in action. All right, so here's I'm on the enterprise page right now, and if you go on policies and actions, it's weird that they've got this section, the policies section, for some reason. But if you go ahead and look at runner groups here, so this is the fleet demo stack that I just deployed, and this is the runner group that got defined by Terraform. And you see we've got like two types of runners or scale sets here for our tests and build. And if we look at one of them. So a scale set will be defined by a set label. So you can't define any label on the workflow level. So you get to define them on the platform level, and it will then ask you to use this in your workflows. So in this case, we've got a set label for our tests and also a build scale sets, and we just go ahead and copy them to and use them in our workflow. So Back to our workflow file. And for our build job, we'll use our build fleet. So, and I've kept the ARM job as it is to use Flex so that I can show you that you can still use Flex while using Fleet. So if you have a one-off job, like in this case, you can still use Flex without having to ask your platform team to define a runner lane just so that you can test something that might not be used again in the future. So this makes it actually flexible. Let's commit this and run it. All right, so while our workflows run, let me show you how Flex and Fleet work under the hood. So in case of Flex, there's a control plane that GitHub pushes webhooks to. So each job that gets queued gets its own webhook that the FlexT control plane then reads, looks at the label, takes the spec that's required, gives that spec to AWS Create Fleet API, which then use that spec to get us the instances that we need. So pretty straightforward there. But in this case, we are getting a webhook, or like a webhook is being pushed into the control plane that we then need to deal. In case of runs on Fleet, there's a runner group that we defined, like I showed you, which has a scale set. And the Fleet D control plane in this case long pulls the scale set API that GitHub provides, which when a job is queued or a bunch of jobs are queued, it just assigns capacity to Fleet D in this case. It just tells you, okay, we want 10 jobs for this scale set, and Fleet D just takes that capacity and tries to fulfill it. So there's no webhook and there's no per job responsibility. It's all about capacity and fulfilling it. So after that, it's just the same. It takes that capacity, looks at the label, takes the spec from the Terraform catalog that we defined, and gives it to Create Fleet again for us to create the instances that we need to run the job. So yeah, that's how Flex and Fleet work. And if we look at our workflows here that have run, we still got the cheap instances for test, and for build, we got the instance that we need. So M7i Flex in this case, well within our range, or like the set range that we put, 2 cores and 8 gigs. And the ARM job still gets the runner that we needed, but through Flex in this case. So a spot instance again with 4 and 16 gig of RAM. So this is how runs on Fleet works. It helps you manage your fleet of self-hosted runners at an enterprise scale right from the platform level, so that there's no workflow label sprawl, and you get an airtight way to run thousands runners for your enterprise or your organization. So that's it, and I'll see you again.